Good morning children. In today's class we are going to learn about cosine formula. A formula that links cos of the angles ABC with the sides of the triangle. Let us remember, if ABC is the triangle opposite to A, I will write small a. This length is small a. Against B, small b. Against C, small c. Drop a perpendicular from A to the base BC. It meets at D. Now, what is cosine formula? If I write cos A, remember how to learn it. You have A angle. Small a square will come with negative symbol. The other two will have positive symbol and the combination will come down. So cos A, I will write B square plus C square minus A square by 2BC. Similarly, what is cos B? Here B angle is coming. So minus B square will come. The other two positive. Denominator the combination 2CA. Now let us remember how to write cos C. C is coming. So I will write minus C square. The other two will be positive. A square plus B square. Denominator is a combination of the two. 2AB. Now this is a trick to remember the formula. Let us see how we derive this formula. Consider the triangle ABC. We know if this is a right angle triangle, as I dropped AD perpendicular to BC. Triangle ADC is right angled. So from which I can write what is the angle here C. So I can write what is sin C and I can write what is cos C. From this triangle, what is sin C? Opposite AD by hypotenuse, that is B. Or I will say AD equals B sin C. What is the other one? Cos C. Adjacent by hypotenuse. I will have DC by B. Or DC I can say B cos C. Now how to work out this problem? Let me start any of the squares. So let me say C square. C square is equal to, this is also a right triangle. So triangle ADB is also right angled. Because it is right angled, how will I write C square? It is hypotenuse squared. I can write AD square plus BD square. What is AD square? From here it is B square sin square C. What is BD square? This I want. The entire length BC minus DC, the whole square. What is BC actually? It is the side against A. So I will write A. And DC we got here. It is B cos C, the whole square. Let us expand. B square sin square C plus A minus B, the whole square expansion. A square plus B square cos square C minus 2AB cos C. Combining these two, where B square is common, I can write sin square C plus cos square C plus A square minus 2AB cos C. What is sin square C plus cos square C? Sin square plus cos square is 1. So I am left with B square plus A square minus 2AB cos C. This is C square in the left side. So this we call cosine formula when I have c square in the left. The right hand side is having cos. I can rearrange and arrive at this model. So bring 2ab cos c here and c square to the other side. Or I will say cos c equals b square plus a square minus c square by 2ab. I can say similarly the other two results. Not necessary a to be here. I can keep b here or c here, and so cyclically changing we get the next two results. Cos b. Remember, when it is c, I have minus c square. When it is b, the other two will come say c square plus a square minus b square divided by 2ca. And cos a will be b square plus c square minus a square by 2bc. Hence, we have proved the formula. So, this is cosine formula where we are linking capital A, B, C, the angles with the sides. In the previous class, we learnt how to link the sides with angles. Then how to distinguish both the formula? There we had only A, B, C. In this formula, I am having A square, B square, C square. So depending on the question, check which formula is suitable. Now, based on cosine formula, let us do some exercise problems. Exercise 3.9, question number 3 in triangle ABC. If cos C equals sin A by 2 sin B, prove that the triangle is isosceles. Let us remember what is cos C formula. It is a square plus b square minus c square by 2ab. How to write sin A and sin B using small ABCs? A by sin A equals B by sin B equals C by sin C equals 2R. Sin A will be A by 2R divided by 2. Sin B will be B by 2R. We can cancel 2R, 2R. See what is left out. A square plus B square minus C square by 2AB equals A by 2B. Again, 2B, 2B cancels. We are left with A. Taking it to the other side. A square plus B square minus C square is A into A, that is A square. A square cancelling. We get B square minus C square 0 or B square equal to C square or B is equal to C. This implies two sides are equal. Small b and small c represents two sides of the triangle. So, two sides are equal in a triangle implies it's an isosceles triangle. So, let us remember, if I want to show a triangle to be isosceles, I need to show two sides are equal or two angles are equal. Here I have arrived at the two sides to be equal. Let us quickly see the problem. Sin A, I can write A by 2R. Sin B, B by 2R. We write it from the sin formula. Cancel 2R, 2R. Now left and right 2B, 2B cancels. Cross multiplying. It is A square. Cancel A square on both the sides. We get B square minus C square 0, giving us B equals C, and hence the problem. Question number 4. In a triangle ABC, prove that sin B by sin C equals C minus A cos B by B minus A cos C. Let us start from a complicated side, that is the RHS, and let us arrive at LHS. C minus A. What is cos B? I can write cos B as a square plus c square minus b square by 2ac. The denominator b minus a. How to write cos c? A square plus b square minus c square divided by 2ab. Let us cancel a here, here also. Taking LCM, 2c into c, 2c square, taking minus sign in, minus a square minus c square plus b square divided by 2c. Denominator, again cross multiplying, 2b into b, 2b square, taking minus in, minus a square minus b square plus c square divided by 2b. This gives me 2c square minus c square is c square plus b square minus a square by 2c. Denominator, 2b square minus b square is b square plus c square minus a square by 2b. Again, numerator the same will get cancelled. Reciprocating, I get the numerator I have 1 by 2c, the denominator I have 1 by 2b. As I reciprocate 2b by 1, 2 and 2 cancels. What is b from sine formula? 2r sine b. What is c from sine formula? 2r sine c. Cancelling 2r, I arrive at the LHS sine b by sine c and hence the problem. As we look at the question, we should think in what way I can relate LHS and RHS. So here I have sine b sine c, which I can think of the small letters, that is sides of the triangle. And we know cos b, cos c also I can represent using the sides of the triangle. The sine formula and cosine formula together helps us to achieve the result. Question number 8. In a triangle ABC, prove that a square minus b square plus c square into tan b equals a square plus b square minus c square into tan c. Let us derive LHS and RHS separately. Show that they are equal. A square minus b square plus c square. As I look at this, I know this is related to cosine formula. So tan b, let us write sin b by cos b. The next step, a square minus b square plus c square into, what is sin b? It is b by 2r. What is cos b? It is a square plus c square minus b square. Remember, b comes, b square will be negative. The other two positive and denominator the combination of the two. Now, this and this will get cancelled. So, we are left with b by 2r reciprocating 2ac, or I get abc by r. So, this is LHS answer. Similarly, let us try RHS. A square plus b square minus c square into sin c by cos c. A square plus b square minus c square into sin c is c by 2r divided by cos c. When c comes minus c square, the other two positive. Denominator 2ab. This and this will get cancelled. We are left with c by 2r into reciprocating 2ab, or I have abc by r, and as I compare, I am able to show LHS equals to RHS, and hence we have achieved the result a square minus b square plus c square into tan b equals a square plus b square minus c square into tan c. we proceed on to projection formula. If I consider ABC as the triangle, how shall I combine again the angles and sides? One side equal to combination of the other two sides. That is, I write B cos of the angle C and I write C cos of the other angle B. So the right hand side is a combination of B and C. Small letters as well as capital letters, that is angles as well as sides. Same way B, the other side must be combination of A and C. I put side A, it is cos C. I put side C, it is cos A. Now tell me how to write C. It should be a combination of A and B. So I write A, it will be cos B, plus I write B, it will be cos C. How to prove it? Consider the triangle ABC. AD perpendicular to BC implies triangle ABD, triangle ADC are right angled. Once they are right angled, I can write what is cos B, cos C like that. Now, this is angle C and this is angle B. Against A, I will write small a. Against B, B. Against C, C. Write what is cos B. It is adjacent by hypotenuse. BD by AB, or I will say BD by AB is C. This implies BD equals C cos B. The same idea from this triangle. What is cos C? Adjacent by hypotenuse. So I will say DC by AC. DC by AC is nothing but B. So from here, what is DC? It is B cos C. Why do I find these two? My question is to find A. So to prove that A equals B cos C plus C cos B, let me start from the LHS, that is A. What is A actually? Side BC. BC can be written as BD plus DC. What is BD? We have done C cos B. And what is DC? It is B cos C, which is nothing but the RHS. Similarly, we can prove the other two results. So, we prove that B equal to A cos C plus C cos A and C equals A cos B plus B cos C, and hence the result. This projection formula helps us in problems having the letters A, B, C. See, all the three sides are involved, but only two angles are involved. So, whenever you have like this way, you can use projection formula. One side is a combination of the other two. Exercise 3.9, question number 11. Derive projection formula from law of sines and law of cosines. What is projection formula? To prove that A equals B cos C plus C cos B. Remember, projection formula, whatever letter comes here, combination of the other two. So A comes here, BC combination will come in the right. How to prove it? Using law of sines. So what is sine formula? We know sine formula is A by sine A equals B by sine B equals C by sine C equals 2R. In the place of B, let me start from RHS, which is B cos C plus C cos B. In the place of B, I can put 2R sin B into cos C. In the place of C, I can put 2R sin C into cos B. 2R sin B into cos C plus 2R sin C into cos B. Now, 2R is common. If I take it out, sin B cos C plus sin C cos B. Or this reduces to sin B plus C formula. Remember the addition formula. Sin B plus C is sin B cos C plus cos B sin C. Now, we are in a triangle in which A plus B plus C is 180. B plus C can be written as 180 minus A. Taking sine on both the sides, 180 comes no change. Second quadrant sign positive. So remember, we used to write this. Whenever sin B plus C comes, I can very well write it as sin A. And 2R sin A is nothing but A, which is the LHS. So we have derived projection formula using the law of sines. Second subdivision, we are going to prove projection formula using law of cosines. Take RHS, that is B cos C plus C cos B. Remember the cosine formula. Cos C is A square plus B square minus C square by 2AB plus C into cos B is A square plus C square minus B square by 2AC. Remember, if I want B square will be negative, the other two positive, combination in the denominator. Same idea here also. B and B cancels, C and C cancels. We are left with 2A, a common denominator. Adding the numerators, it is A square plus B square minus C square plus A square plus C square minus B square. So plus B square minus B square cancels, plus C square minus C square cancels. We are left with 2A square by 2A, that is A, and A is the LHS. So we have proved projection formula using the law of cosines.